Hello everybody. In this video, I will help you with your final exam preparation. I will discuss the 2024 Gauteng Prelim Paper 2 Question 8. In the diagram below, the circle passes through A, B, C, D and G. AD is the diameter of the circle. That's very important. Since this is the diameter, angle B2 will be 90 degrees, angle in semicircle. BD and AC intersects at H, and angle AGC is 58 degrees. That's this one. Number 1, determine with reasons the size of B2. Now, where's angle B2? Oh, we have that one. Angle B2 is 90 degrees. Angle in semicircle, since it was given that AD is the diameter. Number 2, B1. So we are looking for this little angle over there. Now let's see. Do you agree? In a triangle, no, not triangle, it is given that AGCB, that is a cyclic quadrilateral. And we know, we have a theorem that says the opposite angles of a cyclic quadrilateral, they are supplementary. So in other words, they add up to 180 degrees. Opposite angles of a cyclic quad. So then we can say that B1 plus B2 plus G is 180. B1 plus B2 we know is 90 degrees, angle in semicircle. G is 58 degrees, that was given, equals 180. 90 plus 58 is 148. Let the 148 walk across, it becomes negative, so B1 is 32 degrees. Remember, it's always good to add it in there. B1, 32 degrees. Okay, from the previous sum, remember, we calculated B1, it was 32 degrees. Now this one wants the size of A2. Now there you see A2, and A2 and B1, they are equal in fact, because they are both 32. The reason is angles in same segment. Since we have a theorem that says when two angles on the circumference of the circle are being subtended by the same arc or chord, then they are equal. And there you can see it's BC that subtends angle A2 on the circumference, but it also subtends B1 on the circumference. So therefore it's also 32 degrees. Number 2, it is given that AB, which is that one, is equal to BC. Okay, let's stop. The fact that they are equal, it implies that angle A3 is equal to C1 because it forms an isosceles triangle, and your correct reason will be angles opposite equal sides. Now the question says, let me show you here, prove that AB is a tangent to the circle passing through A, H and D. So in fact there's an invisible circle. No wonder we don't understand maths, because the stuff is invisible. So let me show you. A, H and D. A, H and D. There's your invisible circle. And AB forms a tangent to that circle. So we need to prove that it's a tangent. So if we can prove that this angle is equal to that angle, then we know it's a tangent. It's the converse of the tan-chord theorem. The angle between a tangent and a chord is equal to the angle in the opposite segment. Now, let's see. We can start by saying that C1 is equal to A3, We know that since it was given that AB and BC are equal, and then the appropriate reason is angles opposite equal sides. Then we can say that angle A3 plus C1 plus B2, which is 90, this one is B2, plus the 32, which is B1. They are all 180, and your reason, let me give you a proper reason there, angles of a triangle. So we can add 90 and 32, we end with 122, let it walk across, subtract, so we end with A3 plus C1 is 58 degrees. But remember, they are equal, so you simply divide by 2, and then you end with angle C1 is 29 degrees, but so is angle A3. It's also 29 degrees. Now we can continue, and we can say that angle D is equal to C1. Have a look. There's D equal to C1. Why? Can you see that this chord AB subtends both angles D and C on the circumference? So angles in same segment is the correct reason there. And then that's the answer. So we have then that A3 is also equal to D because it's also 29 degrees. Remember we said it's 29. So what can you see? That they are equal, and in fact A3 is then the angle between the tangent and the chord is equal to the angle in the opposite segment. So it's the converse, the opposite of that theorem. Because that theorem says if there is a tangent, then the angle between the tangent and the chord will be equal to the angle in the opposite segment. Now we have a situation where the angle between the tangent and or between a line and a chord is equal to the angle in the opposite segment. Therefore, that line isn't just a special line, it's in fact a tangent. So you can say AB is a tangent, and your reason is it's the converse of the tan-chord theorem. Thank you for watching my video. If you click on the video in the left-hand corner, it will take you to the next video of this paper, and that was question 9, and that one was also on Euclidean geometry. And then you will see on the right hand side I added 2 playlists for you. The one is the grade 11 playlist with a lot of videos and a wonderful strategy on Euclidean geometry, and then at the bottom there you will find the grade 12 playlist on Euclidean geometry.